Recently, I bought this ordinary balloon, and now the same balloon is trying to set fire to this piece of newspaper, like this magnifying glass which focuses the solar radiation here. I think all of us have done something similar when we were kids. This is just the beginning of my experiments and the beginning of my attempts to create something like these balloons for converting solar radiation into electricity, or something like this big balloon for generating heat from solar energy, and I will describe all this 6 minutes later. So, my balloon is trying to be like these solar heaters. We know that this concave mirror focuses solar radiation at this point where we can place a heat engine or similar absorber or other device for converting solar energy into heat or electricity. Therefore, we can meet similar solar power plants based on a large number of mirror parabolic dishes. My balloon in the same way focuses the solar radiation, and its mirror is the inner surface of this side. But I had to make this second side transparent, so that it does not block the sun rays and they are focused by this concave mirror surface. Now I have temporarily added a piece of paper so that we can better see this spot of solar radiation which is focused by the mirror side of my balloon. It is obvious that this spot should be focused inside this receiver, which must convert the solar energy of that spot into thermal energy, and let's take a closer look at this receiver. This is one of the options for the receiver, and we see that it has this small window. In addition, we see thermal insulation and this black tube for the circulation of heat transfer fluid. Such tubes can have a very simple manufacturing technology through the stamping of a conventional pipe. Of course, we can make it so that the water of this tank will circulate through the receiver and be heated by that spot of solar radiation to a temperature in the range between 30 and 80 degrees Celsius. So, this balloon can do the same as similar solar collectors which are usually used for hot water supply of a house, for its space heating, for heating water of a pool, or for heating a greenhouse. But my goals are more gigantic, and I want to prove the economic feasibility of some types of solar stations which consist of a large number of balloons. These balloons should produce a large amount of cheap electricity, similar to these well-known solar power plants. Or they should produce a lot of cheap thermal energy for various factories and plants, like these solar collectors which generate heat for copper production. Or our balloons should supply a large amount of thermal energy for district heating of cities, like these solar collectors. My goals are described by this formula, which requires a reduction in the cost of our solar heat to a level of half a cent per kilowatt hour, and it is approximately 10 times cheaper than the cost of heat from natural gas. Here we see that I am aiming for the cost of our balloons on the order of several dollars per square meter of their concave mirror, for their lifespan of several years, and for the simple and quick replacement of old balloons with new ones. Let's look at how I made this balloon, and this is how the balloon was when I bought it. We can understand that its factory manufacturing is very simple, and it is made from two polymer films costing less than $1 per square meter. That is why these balloons can be very cheap. Now my balloon is filled with helium, which is very expensive, and therefore we have to fill our balloons with normal air. I remind you that I must remove the mirror layer from one of the two sides of the balloon, and now I will show you how I did it. Now I am pouring a well-known household cleaner into a plate. We have to carefully coat one side of the balloon with that liquid, and it is desirable to avoid getting the liquid on the other side of the balloon. After that, I will remove the remains of the destroyed mirror layer and that liquid with water and paper napkins. Now I remind you how my balloon looks after I removed the mirror layer from this side. Then I installed this plastic ring, which displaces this transparent surface inside the balloon. This was required due to the fact that the focus point of my balloon was located inside it, behind this transparent surface, and setting the ring moved the focus point outward of the balloon. Now we must pay attention to this spot of solar radiation from the mirror surface of the balloon, which already has the plastic ring. We can notice that the focus point is here, at a distance of about 5 cm from this transparent surface, and increasing the distance increases the defocusing of the spot. In addition, we see that the spot is also defocused near the transparent surface of the balloon. Now I remind you that our type of solar heaters must have a system for turning our mirror according to the movement of the sun across the sky. Cheap varieties of such systems for our cheap balloons will be the topic of my future videos. In addition, I want to test various ideas for placing our balloons on the surface of the water, similar to these solar power plants on reservoirs of hydropower plants and other bodies of water. This idea is also interesting due to the fact that a solar heater on the water can be easily rotated according to the movement of the sun across the sky, and this idea is well known for the case of these solar panel power plants. Of course, I am not the first to try to use cheap balloons to convert solar energy, and this was the first attempt made about 10 years ago by one of the American companies with this name. They proposed to build such a power plant where the mirror surface of their balloon focuses the solar radiation on this small solar panel, which we can also see here. The Americans say that their mirror balloon has these features, and we see that its cost can be about $1 per square meter of mirror, and it is able to withstand strong winds. Let's look at this second attempt, which was made by an Austrian company with this name. It works in a similar way to these well-known solar heaters, which turn according to the movement of the sun across the sky. This Austrian receiver is a path for heat transfer fluid, which can be heated by solar energy to a temperature of almost 600 degrees Celsius and transfer the energy into this heat storage. The thermal energy of this heat storage can be used to generate electricity both day and night, 24 hours a day. In addition to generating steam for electricity, the Austrians offer these uses, including water desalination, heat for industrial processes, solar cooling. My idea is to build large solar power plants from a lot of balloons which heat thermal oil inside such receivers with a temperature of about 300 or 400 degrees Celsius. Thus, we take an example from the type of solar power plants where thermal oil circulates through a variety of pipes, is heated inside these receivers by solar energy from mirrors, and transfers this thermal energy to the center of power plant. This thermal energy produces steam for a turbine with an electric generator and accumulates in similar heat storages to be used for the same turbine at night and during non-solar hours. I remind you that I will aim for this cost of heat, half a cent per kilowatt hour, which allows the production of cheap electricity at this cost, 5 cents per kilowatt hour. This formula was explained in this more recent video for the case where our large heat storage not only provides energy for the electricity production at night, but also transfers a large amount of energy from sunny summer to non-sunny winter. I will continue to explore and describe a variety of ideas which should lead to the fact that our balloons will be able to produce cheap heat and electricity. But it is obvious that these ideas still have many problems and disadvantages, and I plan to do various experiments to investigate these disadvantages. Therefore, one of my future videos will describe their disadvantages and try to answer the question of what exactly should we improve in order to make our solar electricity better and cheaper than electricity from thermal and nuclear power plants. In addition, I will explain why these factory balloons are not well suited for the production of thermal energy, and we will have to make our balloons ourselves from a similar very cheap film, trying to connect it in this way or in some other way. My measurements came to the conclusion that the flux of solar radiation from a balloon of this film is about 10 times greater than the solar radiation from this factory balloon. And I plan to investigate this phenomenon in more detail and describe its results in one of my future videos.